We now continue with section 6.2. So we are looking at trigonometry of right triangles. So if you have a right triangle, so you know that it must have one of the angle 90 degree. Well, we cannot have more than one equal to 90 because then it will not remain a triangle. So one angle is 90 degree and the other two are acute angles. It means they are both less than between 0 and 90. So now the 90 degree angle is shown by this symbol, whereas the others are shown by an arc like this one or this one. So we know that the sum of the angles of inside a triangle, there are three of course angles, the sum of these three angles is 180 degrees. In a right triangle, because one of the angle is 90 degree, so that we are left with the sum of the other two angles is equal to 90 degree. Now the sides of the right triangle have special names. Well, in general, these two sides are called legs, and this side which is opposite to the 90 degree angle, see it's opposite to the 90 degree angle, this is called the hypotenuse. The other two sides in common in general are called legs, but in particular the side that is opposite to your angle theta, for example, like the whatever angle is you are talking about in, or we name it, or we are given, maybe like in this case theta is the given angle, then the side opposite to that will be called the opposite, and the side that is adjacent to the angle, it means the side which one of the sides which makes up the angle along with the hypotenuse, that is called the adjacent side. So notice here, these are the two sides that are making up the angle theta. We call them, one of them is hypotenuse, the other is called adjacent. Now if we have another angle over here, if we call it phi, then theta plus phi is equal to 90 degree. Also the side opposite to phi will be the side which is adjacent to theta, and the side which was opposite to theta becomes the adjacent side for phi. Okay, so now you can name these sides whatever you want, but what is important here is that to the right triangles we can apply the Pythagorean theorem. What is the Pythagorean theorem? It says, according to the Pythagorean theorem, hypotenuse square means length of the hypotenuse squared is equal to length of the opposite side squared plus length of the adjacent side squared. So we have the Pythagorean theorem which always works for the right triangles. So we can have different names, so accordingly you can adjust the names in this equation. So now we will talk about trigonometric ratios in terms of these opposite, adjacent and hypotenuse. So sine of theta is opposite over hypotenuse, so we can write it as O over H. Cosine of theta is adjacent over hypotenuse, so A over H, and tangent of theta is opposite over adjacent, so it is O over H, A. So this makes a mnemonic, SOHCAHTOA. Often students remember this to remember these ratios. So now we can look at some examples. So first example says, find the exact value of the 6 trigonometric ratios of the angle theta in the triangle. So now here we are given some information. So what we are given, the first thing, this is the angle theta over here. So the side, one of them is 8, the length given is 8, and the other leg has this length 15. So according to theta, the opposite is 15 and the adjacent has the length 8. So since we need to find all 6 trigonometric ratios, we need to know the length of all the 3 sides. So we can find the length of the hypotenuse by using the Pythagorean theorem, and we end up getting h square equal to 289. Square root of 289 will give me 17, because that is the square root of the 289 is 17. Now I didn't write plus minus here when I took the square root. The reason is because we know that the length of, we are measuring the length of a side of a triangle, and length can never be negative. Once you have your O, A and H, you can just use the SOHCAHTOA and write all the 6 trigonometric ratios that I have seen here. Looking at the second example, now again we now know the opposite and the hypotenuse, because the angle theta is up here. So we know the opposite, which is 7, and the hypotenuse, which is 10. So we have to find the adjacent side. So again, by using the Pythagorean theorem, I found that A is equal to square root of 31. Now we will use the square root of 31 as our adjacent side and write down all our trig ratios. Now once, if this square root is coming in the denominator, you should simplify, rationalize it, and bring it to the numerator, and you know how to do that, and I have done it here in one of the pieces. Now if it is coming in more in the denominator more than once, you can do the rationalization only once and then use that rationalization in the other place if you can. If you do not know how to, then every time you should rationalize. Okay, next example says find the side labeled X. State the exact answer and then approximate it to 5 decimal places. Okay, now in the exam you will not be asked to approximate to 5 decimal places because you won't have the calculator. But at home you can do it. In the homeworks you can do it. Actually, WebAssign asks you to find the answer in decimals, so that's why you should know how to do that. So here, first example, the triangle has this side written as 4. This side is X. So one leg is 4, the other leg is X. Now, can we find the hypotenuse? Yes, we can. Do we need to? No, we don't need to. Because the thing is, what is expected of you is that you use a trig ratio which involves these 3 things: the X, the angle, and the side which is given. So if you notice, the given side is the opposite side, the 4, and the X side, which has length X, is the adjacent. So what is so it means this is opposite O, and this one is A, and this is our angle 30 degree. So O and A, which ratio uses O and A? The tangent. So you can say tangent of 30 degrees is equal to O divided by A. So here I have done it to show you. So if you cannot see directly, you can write the three terms here and then check which one. So this is the one we will use. So tangent of 30 degrees is equal to 4 over x. But what is tangent of 30 degree? We know that square root of 3 over 2. So we use that, and then on the right side we have 4x. Then cross multiply, and it simplifies to x is equal to 4 into square root of 3. So this is the exact value, and now you can take a calculator and approximate it to decimals. Whatever number has been asked, they said approximate to 4 decimal places. So we have the value 6.9282. Looking at the second example now. So now x is the hypotenuse, and the side that is given is the opposite, and the angle is 53 degrees. Oh, by the way, one important thing I forgot. So when you do this calculation, actually it won't matter here because we we can use the ratio. We know the value of tangent of 30 degrees from the table, because 30 degrees, remember, equal to pi over 6. But if you plug in your calculator and try to find this value, you have to make sure that the angle, your calculator is in degree mode. So I hope everyone knows how to check that. Okay, now second example. So we are given the opposite, and then we are given the hypotenuse. We have to find the hypotenuse. So a trig ratio that involves the opposite and the hypotenuse and the angle is the sine of theta. So sine of theta is equal to opposite over hypotenuse. Theta is 53 degrees. So it means sine of 53 degrees is equal to opposite, which is 25 divided by x. So cross multiply and then simplify. We get x is equal to 25 divided by sine of 53 degrees. So this is the exact value. And then you can plug in the calculator, but again remember that the angle must be in the calculator must be in degree mode. Okay, I will stop here and continue in the next video.